Good morning, my YouTube viewers. It is Crystal here. I'm just here this morning because I wanted to do Seaborn's data set on sea ice, because now that we're in the summer and it's so nice and warm and lovely, there's lots going on about climate change. They used to call it global warming, but now they call it climate change. And the thing is the last year or two, I did a time series on global temperatures. It was either global temperatures or Australian temperatures, but it was actually temperatures. And whenever I did this time series on temperatures, it transpired that the temperatures are actually increasing. So all factors being the same, if people keep going in the direction that they're going in, the temperatures are going to increase. And of course, I like warm weather, but they say that it's going to have a devastating effect on the environment if the temperatures keep increasing. And so this year, I know that Seaborn has a data set on sea ice. And so I wanted to check out sea ice and see what's going on with sea ice. And so that's what we're going to do. We're going to use Seaborn's data set on sea ice. So the first thing we did was we created a program in Google Colab, which is a free online Jupyter notebook sponsored by Google, and it's a great platform to use if you're working on Python, but it doesn't have a very good undo function, so you need to be careful not to accidentally delete or overwrite any valuable code. If you do delete or overwrite valuable code, you can always, there's a possibility that you can get it from the saved history, but it's not a guarantee. So don't think that you might not get it back. So that's why you need to be careful. So after I have created the Jupyter notebook, the first thing I want to do is I want to import my libraries. So the libraries we're going to import are pandas as PD, and what that does is that creates data frames and processes data. We're going to import NumPy as MP, and what that does is creates NumPy array and performs numerical computations. We're going to import at some point Tensorflow, which is what's going to create our deep neural network, and in this instance it's going to be a LSTM, a long short-term memory. We're going to import matplotlib.pyplot as PLT, which visualizes the data, and we're going to import Seaborn as SNS, which statistically visualizes the data. So now what we're going to do is we're going to use Seaborn to load the data set, and the first thing we have to do is we have to see which data sets are in the Seaborn library. So we're going to look at the sea ice data set, and what that's doing is telling you how much sea ice there is. So df equals sns.load dataset sea ice, cache equals true, data home equals none, df date equals pd to date time df date, df equals df set index date df. So now we've got the data frame with the date being the index and the numerical, and have only one column called extent. So you can see here from 1980-0101, the extent was 14.2, and so from 2019-1231, which is about 40 years, the extent was 12.889. So you can see in 40 years that the sea ice has actually gotten smaller. There's not as much sea ice there. So strictly speaking, we didn't even need to do a Python program to check out the Seaice because you can look at the figures and see. But I wanted to go ahead and do this program anyway. So we're going to check the info. So we have only one column. Your date is actually your index, and you have only one column, and it's called instant, and it's the float 64. So now what we're going to do is we're going to plot it. So this is a plot of every single plot, and you can see even though they plotted every single plot, you can see how the figures are making a slow decrease. So you can see that right there, a slow decrease in the figures. But what we're going to do is we're going to resample it. And I decided that I was going to resample it by the year. And when we resampled it by the year, you can see quite clearly that from 1980, the extent was less than 12.5 to 2020, and the extent is less than 10.5. So in 40 years, the Seaice has lost 2 points. So that means all factors being the same, the Seaice is still going to continue to decrease unless we do something about that. So now we're going to prepare the data function, and I got this from Chris Snake. And so this is what we're going to do, is we're going to prepare the data. So XY is to list for I in range, len times series data. Says you find the end of this pattern, end IX equals I plus end features. Check if we are beyond the sequence. If end IX is greater than len times series minus 1, break. And then we gather the input and output parts of the pattern. SEQX and SEQY equals time series data I to end IX time series data end IX. X dot append SEQX, Y dot append SEQY, and then we return NP array X and NP array Y. So now we're going to say time series data equals DF here. Choose a number of time steps. In this instance, we choose 3. Split into samples. X, Y equals prepare data, time series data in steps. Print X, print Y, print X shape. So here we've got print X. It's an array with 3 columns. We print Y. It's an array with 1 column. And the shape of X is 37.3. So now we say end features equals 1, X equals X shape, X dot shape, no, X equals X dot reshape, X dot shape 0, X dot shape 1, and end features, and then you check X dot shape. So the shape is 37 by 3 by 1. Now we're going to build the LSTM model. That's the long short-term memory model. And I'll just come up here. A long short-term memory cell can process data sequentially and keep its hidden state through time. A common LSTM unit is composed of a cell, an input gate, an output gate, and a forget gate. So that's your LSTM model. We also were going to import Tensorflow and import all of the modules associated with Tensorflow. So model equals sequential, name equals Seaice, model.add LSTM. We're going to have 20 neurons. Activation equals ReLU. Return sequences equals true. Input shape equals end steps in features. Model.add LSTM 20, activation equals ReLU, model.add dense, 1 neuron, and the activation is going to be linear, and then we check the model summary. Now we're going to compile the model using Atom as the optimizer and MSE as the loss, and we're going to fit the model. history equals model.fit, xy, epochs equals 300, verbose equals 1. So you can see the loss. The loss has gone down. And now what I did was I created a little chart so you can see the loss, and you can see that the loss has very gradually gone down. Now we're going to make the predictions, and again this was inspired by Chris Nate. So input x equals np.array y, and it's the last three values of y. Temp input equals list, x input, list output is a blank list, and I equals 0. I is less than 10. If len temp input is greater than 3, x input equals np array, temp input 1 to the end. Print year input format I x input. X input equals x input dot reshape 1 in steps in features. Y hat equals model dot predict x input verbose. Print year output format y hat. Temp input dot append y hat 00. Temp input dot temp input 1 to the end. First output dot append y hat 00. I equals I plus 0. Else x input equals x input dot reshape 1 in steps in features. Y hat equals model dot predict x input verbose. Print y hat. Temp input dot append y hat 00. List output dot attend y hat append y hat 00. I equals I plus 1, and it says print list output. So we've got a printout of everything. It says first year all the way to the 9th year, and then we get the list output. So that's telling you what the output is. And now what we're going to do is we're going to visualize the data. Day new equals np.arrange 1 to 10. Day pred equals np.arrange 10 to 20. PLT plot day new np range y neg 9 to the very end. PLT plot day pred list output, and then so you can see that it has plotted it on a graph, and so you can see that it started out at 10.5, and then it decreased to 10, and you can see that with the predictions it's just going down. It might not, in real life it might not go down that far, but it's just going down. So all factors being the same, if people don't change their ways and we don't do something, then the sea ice is going to continue to decrease. And so that's it. That's the prediction of the sea ice using LSTM. So we had a prediction of 40 years roundabout. Not a prediction, but we had 40 years of data, and you can see how the sea ice is continually decreasing. And then we predicted 10 years on top of that, and you can see that the prediction is going to continue to decrease as well. So that's it for the sea ice data set, and that's what I wanted to do now that we're in the lovely, beautiful summer with nice, warm weather. I wanted to see what's going on with the sea ice, and so we've been able to see that. And so I'm going to conclude this video. I would like to thank all of my subscribers for watching my videos. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, then please tap onto the bell button next to the subscribe button. And thank you so much for watching this video. I look forward to making more code reviews for you in the future.